My name is Paul Brees-Gerlich, Applications Engineer for Practical Instrument Electronics, manufacturers of PIE Calibrators. Today I'm here to talk to you about tools you can use for loop troubleshooting. What is loop troubleshooting? Well, let's just suppose the control room has called you in and said, we're having a problem with loop number 7. You go to loop number 7, you start calibrating the transmitter, you check the inputs to the control sensor. Nothing seems to be out of whack. You try replacing the transmitter, call back the control room, they say, no, we're still seeing some kind of issues. Now maybe you start looking at the loop. We're going to show you how to use a PIE Calibrator with built-in loop diagnostics to help you determine whether there's a problem in the control instruments or in the loop itself. PIE's patented loop diagnostics are built into many of our calibrators, including for milliamps, the 334 Plus automated milliamp loop calibrator and the 434 automatic diagnostic calibrator, the model 532 milliamp and voltage loop calibrator, as well as some of our multifunction calibrators, including the model 830 process calibrator and the model 850, which is designed for both 4 to 20 and 10 to 50 milliamp loops, as are often found in nuclear power plants. For today's demonstration, we're going to be using the PIE Cal 334 Plus automated milliamp loop calibrator. This is a standard 4 to 20 milliamp calibrator with the built-in loop diagnostics. As a standard milliamp calibrator, it's set up with an easy check switch. It goes from 4 to 20 milliamps, or allows a middle position, and also allows you to dial with both 0.001 milliamp resolution or 100 times that for faster dialing, just by pressing and holding in the knob. Again, it will source 0 to 24 milliamps. It will read up to 52 milliamps. It will also read DC volts, plus or minus 99.99, to allow you to check your loop power supplies and batteries, and it has a built-in transmitter simulator. Today we're going to be using it to power up a transmitter while simultaneously reading back the current and see what our loop diagnostics technology is all about. This is a demonstration of a typical 4 to 20 milliamp loop in a process plant. This loop happens to have a RTD transmitter as the input, a 4 to 20 milliamp indicator in the control room, and a junction box. This loop just happens to get a little bit flaky right after a major rainstorm. To run this demonstration, we're going to turn the PIE Cal 334 Plus until it reaches full scale. What it's doing now is supplying the 24 volts to the transmitter while simultaneously reading back 4 milliamps. Again, the control room is also seeing 4 milliamps. Simulating 100 degrees C on the RTD input, we're now showing 20 milliamps in the control room, 20.003 milliamps on the calibrator, and if you look at the bottom part of the display of the calibrator, it's showing a leakage of 0 milliamps. Switching to approximately mid-scale, 50 degrees C input, the control room is now again seeing, in this case, 12.01 milliamps, and the calibrator is showing 12.013 milliamps, 12.012, and again showing leakage of 0.01 milliamps. Now, as I said, this loop gets a little bit flaky when it rains. In this case, we're going to simulate that flakiness by switching from our dry junction box to a flooded junction box. This is simulating rain getting into one of the conduits and flooding out a junction box. Now the control room is seeing the effects of the water in the conduit box fluctuating between 12.18, 12.25 milliamps. You look at our calibrator and it's showing 12.233 milliamps, saying that there is something wrong with the loop. And if you look at the lower part of the display, it's saying that there is a current leak of 0.23 milliamps. This is indicating current that is uncontrolled in the loop versus the controlled current of exactly 12 milliamps being put out by the transmitter. With anyone else's calibrator, you would calibrate the instrument or possibly even replace the transmitter, put it back in the loop. The control room is still going to see a problem. If you used our calibrator to power up the loop, let's say disconnect the PLC, put it in its place, it's going to tell you there is some kind of current leakage that's uncontrolled in the loop. So instead of replacing instruments, you walk around the loop, find the junction box that's got the water in it, open up the cover, dumps all over your boots. Once the junction box is emptied and dried out, the control room goes back to seeing 12.01 milliamps. Our calibrator is also displaying roughly 12.009 milliamps, and again the leakage is now back to 0.01 milliamps, or essentially no current leakage in the loop. Isn't that a lot easier than replacing instruments? And that's how simple it is to use a PIE Calibrator with patented loop diagnostics to find a problem in a loop in your plant. Thanks for watching. To learn more about the PIE Cal 334 Plus or any of our other milliamp, voltage, thermocouple, RTD, frequency, pressure, or multifunction calibrators that are designed and manufactured in Rochester, New York, please go to www.piecal.com.